Signals for front-end developers are blowing up on Twitter right now. And you might be asking yourself, what are they? How do they relate to me as a React developer? And am I missing out on anything? So what I'm going to do in this video is we're going to walk through 4 different examples of signals. We're going to walk through solid signals, Qwik signals, and then 2 on React. And by the end, you'll understand a little bit more about what signals are and when you should use them. Let's get right into it. What signals are can be a little bit vague, but from the conversations I'm seeing, what most folks reference as signals are the signals that are implemented in Solid.js. So that's where we're going to start. We're going to build out a Solid.js application, and we're going to see how signals work in that application. And there's 2 fundamental parts of signals in Solid. The first is that it is a reactive state management system. It models data in a reactive way. And the second is that Solid inherently does fine-grained updates. What we're looking at as we dig into Solid is a good understanding of what reactive state management is. Then as we migrate into React, we'll talk about how signals work with the VDOM and how that fine-grained updating works. So by the end of this, we'll understand both of those key concepts. Now let's take a look at our example application. We're going to re-implement this application in 4 different ways. This is the Qwik version. It's pretty simple. It has the name of the framework at the top. It's got a list of the users that we get from an API. That's going to show us how asynchronous behavior works here. We have a filter, and then we can type into the filter, and that will then filter down the result set to just what is in that filter. And that shows us the client-side interactivity and also how relationships in reactive state management work. Okay, let's go build out the solid start version of this. So I've got my VS Code open to the root directory of the GitHub project that is associated with this video. The link to that is in the description right down below. And we're going to start by creating our solid variant directory. That's going to be where our solid.js version is. I'll go into that directory. And then from there, I'm going to initialize our solid start application by doing npm init solid. Now I've got some options here. I'm going to choose Tailwind CSS because it's kind of the lightest of the boilerplates. I'll give it server-side rendering and TypeScript. And then from here, I'll do an npm install. And then we'll fire it up. All right, looks pretty good. We have some basic functionality in there. Let's go take a look at what the files look like. So we have a source directory. The first thing I'm going to do is hack on some CSS. So I'm just going to remove the Tailwind. And then I'm going to put in some very simple CSS that just makes things large, has a little bit of padding on it. Let's go take a look at what that did. Yep, clean that up. Now we'll go and clean up the root template. I want to get rid of the about and home and just have the basic page. So I'll go over to the root.tsx and get rid of this navbar. So this is our solid variant. And then get rid of a bunch of this. Okay, let's take a look. Yep, nice. Super clean, good starting point. So now let's go over to our index route. All right, this is our index route. Solid start is a lot like Next.js, but basically for solid. It's a solid start. All right, let's go and trim this down. And then I will put an H1 in there. Just say this is the solid variant. And I'll get rid of everything else. Cool, a good starting point. Now let's start off building a page kind of from the top to the bottom. The next thing along the line is our filter input. So we need a way to track the state of that filter input. To do that, I'm going to use create signal. I'm going to bring that in from Solid.js. And this signal I'm going to define globally. You can do that in Solid. You can define signals wherever you want to, and that's really nice. So I'm going to put the filter right at the top here. And I'm going to initialize that filter to just an empty string. And then down in our return, I'm going to just add our input. Now the trick here is that I don't just say filter, I call filter. And what that does is it subscribes this component and this particular input to the value of filter. This is actually where the fine-grained updating comes in. When filter changes, Solid is going to change just the value on this input. That is how precise. That's why they call it fine-grained updating. And then we have an on input, the equivalent in React of on change, where we call set filter. So how do we know if it's working? Well, let's just bring in a div that shows the current filter value. All right, let's take a look. So pretty easy. Now, the next thing we need to do is we need to call this recres API. This is just a free API that you can get users from. So we're just going to call the list users function. That's going to give us back a big response that has some data in it. That data is going to have a bunch of users, and we're going to use that as our data source. So much like Next.js has a get server-side props, Solid Start has a route data function that you can export, and that route data is the one that does any asynchronous requests that you need to go get your data for your route. So let's go and implement on that. Now within our route data, we need to make an asynchronous request. And the way that you model data from an asynchronous request in Solid is that you use a resource. So we're going to bring in create resource, and we're going to call create resource to create a resource within our route data. That is first going to go and await the fetch of our recres.in API users route. And that's going to give us back a response. From that, we need the JSON, which will also await. And then from that response payload, we're going to get the data part of that. And that's going to give us our users, which we will then return. But of course, this is TypeScript, so we do want it to be strongly typed. So let's go and specify a definition of what we're going to get back. In this case, we're going to get back user data. And so we can say that this resource is basically just an array of user data. Okay, so now we have our route data with our users. Now, how do we get it into our home component? Well, to do that, we need to use a hook. And that hook is use route data. And you can call use route data within your component to go and get the list of users. And the nice thing here is that you have some strong typing. So now if we do Command K, Command I, we can see that users is a resource that has an array of those user data. Now we want to display those users, but we should have a component that does a nice job with that. So let's bring in a component called user that we give it a user, and it goes and puts out a div with first name, last name, and email. So now we have our list of users and we have our user component. We need to go and then iterate over those users and put them onto the screen. And the way that we do that in Solid is we use a for. Let's bring that in. So it's not like React. You don't have map. You have this for. And with that, you can then iterate through users. You can even give it a fallback when it's loading. And then you give it a function as the children, and that function gets called back with the value, and then you do whatever you want with it. In this case, we're going to go and build out that user component. So let's try this out. Okay, looking pretty good. We have our user list from our resource. We've got our filter that we can change. Now we need to go and create a list of filtered users. And that filtered users list would depend on both the filter and also the users. So how do we do that in Solid? Well, let's go back into our code. So to do that, we are going to create a memo. And a memo is just another type of signal. It's a computed signal, and it depends on other signals. So we can also create that anywhere we want. In this case, we have the users data here in home. We have the filter data as a global. So actually, the most convenient place for it would probably be right here inside of home. So we'll call create memo. It'll take a function, kind of like useMemo in React. You're going to take the users and then filter them based on the filter. Okay, pretty cool. So let's go and take that then filtered users that we got and replace users with that. Hit save. And now over here, perfect. Awesome. And this is reactive state management. Let's go take a look at the code again. We've got signal for the base types, like just filter in this case. We've got a resource for asynchronous data, and we have create memo, which allows us to compute data based on existing signals. And when any of those signals change, it automatically changes for us, which is just super cool and easy. Now, if you're looking at this and you're saying, wow, a lot of these names seem very similar to useState and useMemo in React, that's true. When you think about it, React actually has a reactive state management system built right into it. The only problem is that it's got dependency arrays, and that makes it a little bit hard to use. Solid.js doesn't have those dependency arrays. By calling, in this case, for example, filter, we are subscribing this create memo to that filter. And by calling users here, we're automatically subscribing that memo to users. So it automatically subscribes to both. And when either change, it changes automatically. And that's basically the core concept of reactive state management. So yes, React has reactive state management built into it. It's just not as clear and nice as this signals-based version. And you know what? That does it for Solid. Let's go take a look over at how Qwik does it. So we'll go over to our Qwik directory and jump in there. So Qwik has Qwik City, which is kind of the equivalent of Solid and Solid Start and React and Next.js. All of these frameworks have effectively the meta framework of something that goes and manages routes and does all of that for you so that you can concentrate on just writing particular pages and letting the framework handle all the routes. In Qwik world, that's Qwik City, and the routes are in the source routes directory. Let's go take a look at index.ts, and we can see how this exact example works in Qwik. So we'll start off with our interface for user data. That's exactly the same as we had in Solid Start. We've got a user component. That is the display component equivalent that we had in Solid Start. And then we have our base component itself. This is like the app component. Now in there, we're going to use a store to manage our filter. That comes back as store. And the nice thing about a store in this case is that you can just reference that value, say store.filter, and then set that value. It's a lot like MobX in that way. All you need to do is just get values and set values. And by getting a value and setting a value, you automatically subscribe. Now, one of the interesting things you'll see in Qwik is this dollar syntax. So anywhere where it's going to be also running on the client, you're going to have a dollar. So in this case, on input is a client-side event handler. So it's going to have that dollar on it. And when we get a new value for that filter, we're going to just do store.filter and set the filter. To display the filter, all we have to do is just reference that filter. And then we got our filtered users. Well, where does that come from? Well, that comes from, again, that combination of filter and users. So let's start with users. Where does that come from? Well, users in this case is a signal. And we type that to be a set of user data. And then we use a task to populate that data. And in this case, that task is going to call the fetch on that API users that we had before. It's going to get back that JSON, and then it's going to set that value to that JSON data. Here's where Qwik is actually really cool. This task actually happens 100% on the server, and then it takes the data and it packages it up for the client. Now, in the React world, they call that hydration. In the Qwik world, they call it resumability. And the notion is that the server stops processing at some point where it's got the users and it's got the filtered users and it's got the initial page, and it basically just pauses in time. And then Qwik handles resuming with no delay that state on the client. And it's pretty cool, and it's definitely quick, a lot quicker than React's hydration. To kind of wrap this up, filtered users is also a signal, also a user data array. And we're also going to use a task to populate that. Now, this task gets given a track function, and that track function is effectively what amounts to a dependency array. You can call that track function and say, hey, whenever you think things might be changing, call me and I will let you know if they changed. In this case, that is when either the user values data changes or the store filter changes. I'm not sure if this is quite the right way to do that in this case. Somebody can let me know in the comments if this is the right way to use track on this. I'm not sure, but whatever. It seems to work, which is a good starting point. So whenever those change, then the filtered user's value has to change, and then we do our filter. There's really nothing all that exciting about it. We're just setting filtered user value. That then goes down to our map. You don't have that for concept in Qwik. You do have that kind of React map concept, so it's pretty similar that way. And there you go. So let me give you my 2 cents on this. I think that there is a good model of reactive state management here. I do think this track is a bit clunky. It reminds me of dependency arrays, and dependency arrays in React are where we get in trouble. So I would much rather us have a way where I could just, by accessing store.filter or users.value, we automatically get subscribed just the way that we do in Solid. That would be really a nice upgrade here. But otherwise, I think this is a really good take on reactive state management. And it also does that fine-grained updating that Solid does, which brings us to fine-grained updating. So if you don't know what that is, let's go build out a little React app so I can show you. So I'll close this out and I'll bring up a terminal and I'm going to go back up a directory. And I'm just going to use Vite to create a very simple React application. I'll call it fine-grained. Not going to use TypeScript. Doesn't really need it. I'll install it and I'll run it. And there we go. We've got our Vite React application. What I want to do is I want to implement just the top of this, just the filter. And then I'll show you how that works first with more traditional React using useState, and then a useRef variant that kind of simulates what fine-grained updating would look like. Okay, so let's just pare this down. And instead of count, it's going to be filter. And instead of a 0, it's going to be an empty string. We'll get rid of app. We'll go tweak the CSS so that it looks similar. Okay, that's a good starting point. Now let's go and add in that input. And then we'll go and add in that filter that shows us what the filter value is. Okay, let's check it out. Perfect, right? React 101. Let's track some state. That's the whole point. Now, what's actually happening here? Because to understand fine-grained updating, we need to understand a little bit more about how React normally works. Well, what's happening is when I call setFilter, that's changing the state that's attached to the component. And the core concept of React is I'm going to take the state and I'm going to turn it into HTML. When the state changes, I need to rerun that component to re-render that component. And then that will create new VDOM elements, which will then get diffed against the older VDOM elements. And what has changed will then be updated in the DOM. And in this case, what that means is we will change the VDOM so that the inner text of this div is going to be different. And then we will go and push that VDOM change of the inner text that now has a different filter value in it to the DOM. So to see this actually happen, let's go over to our arc again and then go into the inspector. And I go over to components and I'll make sure that the highlight updates when the component renders is on. Now, as I type, we can see that everything is highlighting because the whole component is getting re-rendered. You wouldn't see that in Solid because Solid doesn't do that. Solid just goes literally in and changes that inner text. Of course, trying to demonstrate that using React dev tools really isn't going to work. So you just kind of have to take it on faith that that's actually happening. Let's go and imitate what Solid is doing in our React app. So the first thing we need to do is avoid the re-render. To do that, we need to use a different way to store the state of filter than using useState. Now, what's a way to store a state that doesn't force an update of the UI? useRef. So we're going to change out useState to useRef. The initial value remains the same, but in this case, we just get back a filter, which is an object that has a current value on it. And that would be the current value of that string. And then we're going to set that current value to the new target value and then show it. Okay, let's try this out. So now we don't get any updates. Yay. But we've broken the functionality. It doesn't actually work because when we set current on a useRef, it doesn't force an update of our component. So now we've got to manually go do that. So to do that, we need a ref to this div. We'll call that the display filter ref. And we'll create up here. And now, in addition to setting that current, we are also going to set the text content of that display filter ref to a new version of that filter. And notice, we actually have to keep the formatting and everything. It's a pain, but let's see. Let's try it out and see if it works. And it kind of works. So what's actually happening there? Well, what's happening there is we have a controlled component. That's because we've set value. React thinks that is now a controlled component. So we need to get rid of this value. And now it works just fine. But you can notice if we have our highlight updates when component render, we don't actually see anything happen when this happens. So that is the core concept of fine-grained updating. You have some data, in this case, filter, and you want to attach it directly to specific DOM elements on the page. Now, I will say Solid is a lot more than this. Solid will go and re-render components and everything else. But when it comes to React and how it does fine-grained rendering when folks have hacked in fine-grained rendering, it's mostly around things like this. You're going to change an individual prop. You're going to change an individual piece of inner text or something like that. It's not like Solid where you can take that signal and connect it to a for and get a whole bunch of components and map the whole state and all that. It is really, in the React case, when folks hack in signals specifically around these very small updates like changing inner text or changing a prop. So let's go take a look at two different ways that folks are doing signals in the React context. And the first one of those is the Preact Signals React library. So it's a library from the Preact folks that works with React to implement signals. Now, there's actually 4 different libraries in this set of libraries. There's a signals core that manages the reactive state management system. Then there is a signals Preact that works for Preact, a signals React that works for React, and another one that works for Svelte. So in our case, in the code that is available to you in GitHub for free, in the link in the description down below, the version uses React and also signals React. So what we're looking at is the Preact version. It is, again, it's the Preact library, but it is a React version. So we have 2 new functions that we're bringing in from Signals React. They might start to seem familiar to you. One is signal. That's going to create an atomic piece of data. And then the second is the computed. So in this case, our filter is going to be a signal that starts with an empty string. Our users is going to be a signal that starts with an empty array. And our filtered users is going to use that computed to then connect the users to that filter. And again, this is doing that really nice solid.js style of signals where I don't have to tell it what I'm tracking. The fact that I use it is what connects me to the track. So in this case, I use users.value, therefore I am subscribed to it. I use filter.value, and therefore I am subscribed to it. Now, to populate the data, I just have a module level fetch that just goes off and gets the data. And when it's done, it sets the user value. The user component is just a standard React user component. And then we have our Preact signals where we have our input. And then instead of calling a setter, in this case, we just set that value. And then we reflect the value down here. Now, what's really cool about this particular implementation of signals is that you can use it to do larger updates. Like in this case, use filtered users to build out a bunch of user components. But the reason that it works is because it doesn't do fine-grained updates. So let's go bring this up in the browser and I'll show you what's going on here. All right, now before I start it up, I am going to use a different command. I'm going to use the start command. That's because this is a create React app application, not a Vite application like the other applications. Why is it a create React app application? Well, this doesn't work with Vite. And the reason that it doesn't work with Vite is that they're doing some shenanigans to patch the JSX runtime to make this work. So, well, let's go take a look at it first, and then we can dig into that. Okay, so let's try it out. All right, that seems to work fine. Now let's go and do our inspector, go into our components, and see what is happening. Yeah, so everything is re-rendering. So this is basically a stock React app with the re-render cycle, just normally re-rendered, not fine-grained updating, but you get the reactive state management. Awesome. So how does that work? Well, again, they are using some JSX runtime magic to connect the filter value and subscribe automatically as you're using it to the component that actually uses it. And then whenever that changes, they're just forcing a natural re-render of the React component. So this is giving us half the equation. It's giving us the reactive state management. Can we get the reactive state management and the fine-grained updating in React? Yes, we can. It's in Jotai Signals. Let's go take a look at that. So this is in the Jotai version, again, available to you in GitHub. Let's go into our app.jsx. If you're not familiar with Jotai, Jotai is a re-implementation of Recoil. If you're not familiar with Recoil, Recoil is an atomic-based state manager originally from Meta. I think it's still from Meta. The idea is that you model all of the pieces of state in your application as atoms, and atoms can connect to other atoms and derive new atoms, and that's what we've got here. We've got the filter atom that starts off as a string. We've got the user atoms, which is in this case an async atom. It automatically goes and gets our API users and returns that data. And then we have our filtered user atom, which goes and connects those two atoms, the filter atom and the value of the user's atom. And then it does our filter. And just like the other reactive state management systems, anytime you change any part of that, you change the filter or you change the users, that filtered user's atom will automatically update. Cool. We have the reactive state management part of the signals paradigm. Can we also get to the fine-grained updates? Well, actually, in this case, we use both a combination of basic React re-renders and also fine-grained updating. The basic React re-renders come from use atom, which is a hook that allows you to connect to an atom and bring that into the React ecosystem as state. And then we have $, which is what allows you to do the fine-grained updating. Now, to make all this work, you have to use this JSX import source and connect it to Jotai Signal. And that's what's going to do a little bit of, and that's where Jotai takes over and layers on top of the basic React render cycle, this additional fine-grained updating when you use it. So it supports this $, down here. Okay, let's go take a look in our code. So the way you see the $, in this case is you see that in the value of the input atom and also this filter component down here where we use $, and we just get the filter value. So if we bring this up, we should see that the filter line doesn't get a component update when we change it. Let's take a look. Okay, looks good. Let's now change it. Nice, so everything's updating properly. Now let's go over here to our inspector. So we can see that we aren't getting React render updates on either the input or on the filter. Nice. The only other thing to look at is our data display down here. That's what's actually showing the list of users. That's wrapped in a suspense because the underlying atom that it's talking to, the filtered user atom, is an asynchronous atom. So let's go back over here, take a look at data display, and we are using that atom and getting the users out of it. And then we're doing a normal React render to get our data. Okay, so I hope looking at these 4 different variations of signals, both in the React context as well as the solid and the Qwik context, gives you a little bit more insight into what signals are, why folks are so interested in them, how they impact our application architectures, and the options that you currently have today in terms of signals in our apps. I will say that there has been some talk from the React team about supporting signals directly in React, also about a React compiler. Of course, that doesn't exist today, so there's not a lot to talk about. Of course, if you like this video, be sure to hit that like button. If you really like the video, be sure to hit that subscribe button and click on that bell and be notified the next time a new Blue Collar Coder comes out.